Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more. Hello, this is Richard Jacobs with Future Tech Podcast. Almost here, Round the Corner Technology. Today I've got really interesting guests. Colin Cantrell, the creator of Nexus coin, NXS. Very, very smart guy. Knows a tremendous amount about cryptography and Bitcoin. So he's going to have a lot of great insights for everybody. So that's why he's here. So how you doing, Colin?
Hey, I'm doing pretty good. How about yourself?
Good. Yeah, thanks for coming. So
yeah, thank you for having me online. I appreciate it.
Yeah. So we'll weave in various topics, but when I spoke to you about Nexus, you told me that a lot of the code and a lot of the reason for creating the coin and the insight came from Bitcoin. So can you talk about what led you to create Nexus coin, and what did you take from Bitcoin, and what do you know about the code?
Well, basically, I could just say I learned from Satoshi, but not necessarily in the respect of Satoshi directly talked to me. It's just, as a computer programmer, everybody thinks differently. That's how people at college get caught cheating. Everybody has their own unique style of code, which shows their logic. I guess you could say a program is just like logic statements, flow of information, how a stored process, everything. So I wanted to start with an earlier code base. I think I started with 0.6.3, which was, a lot close to Satoshi's original code, because I wanted to learn from Satoshi in order to say, all right, well, here's Bitcoin. Now I can spend time in isolation just learning how he thinks, learning by, taking it apart and putting it back together and finding how to break it and all these other things. And then assessing how the industry grows and evolves and saying, okay, well, now we can see some of the issues that have been arising with Bitcoin, and now we can do something about those issues by providing new technology on another blockchain that's kind of, for lack of better words, a testing bed, but it's also, an incubation chamber, which, a lot of the designs and all the technology I've built in Nexus spawned from, those 9 months to a year that I just was in that code and learned everything, where everything went, and learning exactly how this individual thought, whether it's a group of individuals or singular, and taking that way that they thought and projecting that forward into providing more technology on top of what's already been made.
So do you have any insights into Bitcoin's code that maybe most folks wouldn't know because you studied it pretty closely?
Well, that's a very ambiguous question, but I guess, are you asking what are some of the limitations I've seen on the code-wise, just in a simple, brief statement?
Yeah. Talk about some limitations you've seen, maybe some upcoming issues that are not being talked about that you think need to be solved, or even the existing ones. Block size debate. Your insight on possible solutions.
Well, interesting enough, the block size debate is. I'll just say the word interesting for lack of better. Satoshi originally had 20 megabyte block size, but they were like, oh, well, this is a large attack vector because at the cost of filling those blocks up, the spam transactions, it's very low. So let's start it at 1 megabyte and then grow it as Bitcoin grows. That's how Satoshi thought about it. Now, it's not necessarily thought that way these days, but that's another thing. Another thing I noticed is the actual socket level backend. Now, I've spent a lot of time in socket programming and different things like that, finding out how to make efficient server systems with, how you design your threading models and everything. Bitcoin basically is just a single thread handling all the data connections, which reads it into a buffer, and it handles all the connection disconnects, timeouts, accepts new connections on the listener on one thread, which, it works to a point, but it's not necessarily balanced. That kind of is one reason things get loaded down. Even Nexus right now is still using that backend is loaded down very slow. And so, block propagation may not necessarily just be an issue of bandwidth. It can also be an issue of the ability to process the message for, when it gets there. Because, you never know. I haven't really done any benchmarks, but if you have a very high transaction volume where they're having to verify the signatures, the ECDSA signature, elliptical curve, digital signature algorithm, you have to verify every transaction signature, and you're getting 2 to 3 transactions per second. And let's say, there's a bit of a backlog already, blocks may come in slower. There may be other protocol messages that may delay it even half a second or 100 milliseconds or even 200, but then you multiply 200 milliseconds through how many nodes it has to get through to finally propagate. That can become 1 to 2, 3, 4 seconds that really can be improved on the code level without having to increase your hardware capabilities, which is what your bandwidth would be.
So what do you think of the current block size debate? What do you think about SegWit versus Bitcoin Unlimited, SegWit 2 megabytes? What do you guess is going to happen, and what's your evaluation of these technologies?
I got to make an educated guess, hypothesis on what happened. I personally think segregated witness is a definite move forward, but then it gets away from some of the original architecture. But, I'm mixed on SegWit. I can't say for or against, because I haven't researched it as thoroughly as I probably should. But it just was something that never really drew my attention because it seems a little bit off the architecture of, the original Bitcoin architecture. Now, Bitcoin Unlimited, I really like the idea that, hey, you know what? We see some of this politics going around with this block size debate. For whatever reason, Chinese miners don't want to do it. Some of them say it's the Great Firewall of China, which will slow block propagation, and they're afraid of orphans. There's also many other things that could be influencing this. So, I like the idea of Bitcoin Unlimited in the sense that, some people say it's an attack, but in other ways, it's kind of like, well, hey, Bitcoin people are trying to take the power back because for some reason miners have the stranglehold on everything. So as we can take this power back and we can push this forward, it's kind of setting a precedent. It is kind of technically a 51% attack if somebody releases a big block, which is going to force everybody to update. But on the secondary perspective, it's kind of like, well, now people have a little bit more of a voice. Now, your node just running, can signal what you accept, whether or not you're a miner or not. And so, I would say that there's probably, just from my understanding of the code, better ways to implement it, but I think it was done just to prove a point and to get things moving in that direction, to get people to start to think like, hey, you know what, we need to figure out how to break this miner's stranglehold. Personally, the way I would do something on the Bitcoin Unlimited level is serialize an unsigned integer into the Coinbase script sig on the input that signals a certain block size. And then, of course, you have the activation of that rule, which is going to read that script and say, okay, now we know there's another unsigned integer, but people should be able to vote the block sizes in miners so that stranglehold can change. So now if everybody's voting 1 megabyte, that's going to make things more difficult. But more people voting, what if you had some sort of average or, it's in a certain bound to say like, well, let's say the average block size that people want miners are signaling is 1.25 megabytes because a lot of them did 1 megabyte and then some say 1.5 megabyte and some say 2 and then average all together the last 1,000 blocks. Hey, bam, now we know like this is a consensus that maybe we should average the consensus together instead of making it directly like 75, 50%, whatever. Why don't we take everybody's opinions and kind of join them together into a block size, which would be really easy to do, which would be a cleaner way to do it, in my opinion, which wouldn't cause forks because that specific way to do it would have to be activated for one, kind of like, say a 50% activation or 75, like SegWit. And then from there, then people can vote for the block size. Now with Bitcoin Unlimited, it's basically like, hey, if I signal I want to accept only 1.5 megabyte blocks and there's 2 megabyte blocks, I'm going to be about however many blocks behind I stay until I'm forced to accept that, which it works. It prevents forks, quote unquote, on the Bitcoin Unlimited nodes, but on the Bitcoin Core nodes, it doesn't. So it could turn into something either really good or really bad. It could go either way, and it really just depends on the intentions of what people do. So, if we're talking about the scaling debate, and let's say I had the ability to make that decision or put out an update like that, that's how I would do it. I think segregated witness is very complicated, and keeping a signature out of the block hash and the transaction hash does prevent transaction malleability attacks, and it does prevent ASIC boost, which is, something that has newly been discovered by, I believe, Gregory Maxwell, where they kind of pre-compute partial collisions, which allows them to mine at about 20 to 30% higher hash rate per, transistor per ASIC than would be before. So, looking at that, SegWit adoption would be kind of difficult to get implemented because ASIC boost, in my opinion, right, it's a natural progression still of the mining industry. Just like people complained about ASICs when there was only FPGAs and GPUs. Well, yeah, of course they're going to complain because they've already invested in a large amount of hardware. But ASIC boost, I mean, it could be good, it could be bad, but if everybody has ASIC boost, then that's the next level of ASIC. And then there may be another ASIC boost and another. And so the fact that there's probably millions of dollars invested in developing that physical hardware, it's going to be really, really difficult to get something like that to adopt, in my opinion, because, there's so much money already invested. So, I mean, why don't we follow where the money is and try to find a way to balance, like, hey, these guys have already invested this much and these guys this much. Like, why don't we find a balance them together? Because it's pretty much a debate of, like, we want to earn more money. And everybody's got their own opinions on how they want to earn more money or how they figured out how to earn more money. So what if we could find a way to kind of help everybody earn money instead of potentially losing money by this, potential civil war?
So, yeah, talking a little bit more about the ASIC boost, is it possible that everyone could use it? I mean, what do you think is going to happen with it? Do you think it's just going to become a commonplace thing?
That I would think so. I mean, think about, like, back in 2013, I remember the Avalon, I think, was the first ASIC chip ever made. Now, that's when they were first start coming out. And there was, like, a couple of open source ASICs. I was thinking of actually starting an ASIC company back then, but I was like, no, I mean, it's just a hardware arms race. It's going to be a big whole mess of overhead and logistics. Like, there's better ways to do it. But, I mean, in comparison, like, to FPGA versus ASIC, I see it as a similar type of comparison where it's just like, at first there's going to be a few people that are going to reap the rewards from it, but as word spreads and it gets more and more public, then they have another form of monetization and say, we have the best ASIC, just like Avalon have the only ASIC. Now we have the only ASIC boost, and so eventually, yeah, I believe everybody would get onto that, which then would move, Bitmain to saying, now let's do ASIC Boost 2.0 or ASIC Super Boost, or, I mean, it's a natural progression. I wouldn't say it's an exploitation of the whole. I mean, from my understanding of it, I mean, I just briefly glanced at the white paper, but basically from what I understand of it, it's pre-computing collisions, which makes it easier so you don't have to do as much computation on it because you can pre-compute a set of data that is going to be more likely to be a hash that's going to win so that you don't have to search through hashes that aren't going to, which, is an optimization to the security model. And, I mean, the higher hash rate on Bitcoin, the more secure it is. So, I mean, should we really be fighting the hardware? I mean, hardware is the most difficult to change. Software is easy to change. So, segregated witness, this may be like a nail in its coffin, and segregated witness may just be useful for Litecoin or, other coins too. I mean, it's not necessarily like it's a useless technology, but it's going to be very, very difficult to basically render this invested money that was invested in generating new hardware is going to render that useless, and that's going to render all of that ROI gone, which is going to be, and Bitmain is a very, very large ASIC producer, so it's an uphill battle, in my opinion.
Well, so you think this could be the secret reason why SegWit hasn't achieved the majority and it's not in place already?
It could very well be, yeah. I mean, as far as I've understood, that's looking like a likely cause. But, I mean, I'm not going to speak in knowns because everything really is kind of unknown unless you, like, talk and see it yourself. So, I mean, that's what I would assume, yes.
With ASIC Boost, so Bitmain is using it. Essentially, it's increasing their hash power by a proxy in a way of, like, for like 20, 30, or 30%, right? It makes the network look like...
Think of it, sorry to interrupt, but just to keep it on the right train, think of it like prime sieving, right? Like supercomputing, we have a prime algorithm in Nexus, and, the initial prime matter I made was just brute force, which, I didn't design it to be efficient at all, but he designed a sieving system and also it optimized it for tuplets to say, why are we going to search through numbers we know aren't going to be prime when we can just jump to spots that we know are going to be more likely to be prime? It's similar to that, from my understanding of it, is like, well, let's find values that are going to be the most conducive to reaching this targeted hash by eliminating all the ones we know aren't going to be that instead of having to go through it iteratively, consecutively. So it's just kind of like finding the hotter spots and hashing, which, is, I think, like there's just a natural progression.
Gotcha. I know the Bitcoin network adjusts the difficulty of the hash problem depending on the hash power. Does ASIC Boost bypass this, or will the network see that, the hashes are being solved faster than before, so now the difficulty will increase.
Well, yeah, if the hashes are being solved faster, the difficulty increases, So if you have optimizations and even like eliminating your need to search for new hash groups, it should definitely be the same. Now, like I said, I briefly glanced at it, so I don't want to speak in, unknowns and speak as I know. But as far as, my understanding of it, yeah, the difficulty should compensate. And it would just be like a normal increase in your hardware, like ASICs were to FPGA.
Interesting. So this could up the game for now for everybody.
Pretty much. I mean, and think about it, higher difficulty, higher security, specialized mining computers, that opens up a whole new market and a comparison, and then that, makes some of the older miners more obsolete, and that opens up a new type of ASIC, which, I personally never would have thought that there was a new type of ASIC. Now, some people say it's a bug that's exploited in Bitcoin. Some people say it's, partial collisions and other things. So it's still really unknown. Like, I might do some more research on this and speak a little more later on it because, it's really kind of interesting, but it's hard to wrap your head around for a minute. But that's my understanding of it just from a quick glance.
Okay. And then, again, from your understanding of the Bitcoin code, do you see any other problems coming up for Bitcoin or other difficulties that need to be overcome?
Well, yeah, I think the biggest problem that we're seeing elucidated from this whole block size debate is specifically the block size debate. So, Bitcoin was in cryptography we trust, right? Cryptography is what controls your money and everything like that. And it's supposedly designed as a trustless system. So based on those intentions from Satoshi, I think he never really got done with it completely. And it was more set out as an experiment. Like, hey, if I were trying a totally new experimental technology and I wanted to test it out, I wouldn't go to every little fine detail because, sometimes you'll go that far and realize, oh, wait, it doesn't work or whatever. So, it's a baseline cryptocurrency with everything that is needed to make it work. But one of the things that, I've spoken on before is the allowable clock drift issue. It's keeping time records, but the clocks being 2 hours apart from one another, even with the median time, can cause some issues there. Some of the back-end code problems and some of the political issues. Like, there's no way to cryptographically validate the votes. The votes are run by the miners, and that's how it was initially set with Satoshi in the white paper. Every block is a vote. So right now, there's less and less and less likelihood anybody can get access to those votes, which kind of creates a global governance system with just a few people representing those votes, which are the mining pools. And the thing is, though, it's all the miners mining on the mining pool that are giving them the power of those votes, which is somewhat ironic. So it's kind of like it's degrading into a similar way that the system is now, where it's just like votes are going to less and less people's hands. They're doing less and less. The Git block template was designed to be able to give people that ability, but it hasn't really taken to that form. So I believe that one of the big things is there needs to be, if there was like Dash has kind of done a little with the master nodes, but that's, again, another type of centralized system that I don't centralized, But I guess if there was more like, how should I say, cryptographic validation of votes that are held in many different areas of input other than just hardware that you use to mine, I think that people's opinions would be not drowned out in the politics of all these political figures at Bitcoin, which would be, all of the main guys. And so it's kind of up to what they say, and they can look at tweet on Twitter and control the price or anything else, and they can say, oh, we're not going to do this. We have 20% of the hash rate, and we're not going to activate SegWit. So people are like, oh, then if they have 20%, then, we're almost pretty much never going to get it because there's 75% that's needed, So, that gives us a 5%, a little bit of squeeze. So it's like, as Bitcoin, I don't think Satoshi anticipated Bitcoin to grow as big as it has. And, the protocol being itself is great. It's solid. It's a baseline. Bitcoin is an amazing storage of wealth. It works perfectly on that front. But political issues is one, and then there's some technological issues that can be, easily mitigated. Like, they had to move from the Oracle DB, like Berkeley DB, into Level DB to make things happen faster. But then the Bitcoin blockchain is 80 to 100 gigs now. So, last time I tried to download it was like 80, 90 gigs. I'm like, man, I need to get a new hard drive just for this. So it's getting more and more into the point where the cost is higher and higher and higher for you to have any contribution to the network, even just running a full node, which is no visible contribution. That's just you can hold your coins on your Bitcoin wallet, So there's a lot of things that I think can be looked at. And so as it being designed as a trustless system, it's kind of at the point where you have to trust what nodes you get it from. You have to trust the developers. You have to trust the political figures, or the, how should I say, public figures would probably be an appropriate word, are true to the principles of it, or not trying to line their own pockets. And why can't we develop, layers on top of the protocol further to expand it, to give more, I guess, the voice to more people? Because, not everybody has an option to change Bitcoin or to help it, even if we believe in it to our utter end. And, that seems like it's something that's kind of can become a honeypot for, let's say, banking systems to start trying to take over, or, who knows, how many of these public figures are actually for the intentions of Bitcoin or not paid off by some other person. So, it's not that I'm saying anybody is, but I'm saying we don't know. And it's very difficult to know. So having more mathematical cryptographic validation of public opinion, I think, is something that's going to do wonders for Bitcoin, which is what Bitcoin Unlimited is trying to do. It's a step forward. But now that Bitcoin's grown so big and the miners have a stranglehold, it's going to be really hard to break that stranglehold. And that's why Bitcoin Unlimited is coming out and saying, hey, well, let's make this change, even if people are going to give us a negative image on it, right? And they're going to say the code's bad or whatever, or this is an attack and blah, blah, blah. That could just be FUD and anti-publicity to get people not to adopt it. But really, Bitcoin Unlimited is taking a major step forward that SegWit isn't, which is giving people more of a voice. And I think that's something that's going to be necessary for decentralization to truly become worldwide and the world to truly be able to adopt it.
Yeah, if I were to ask you what changes you would make to Bitcoin to make it better, safer, more democratic, et cetera, that's probably the reason you created Nexus. So maybe you can go over a few features that you built into Nexus, that you see as an improvement on Bitcoin.
One little thing is, I don't know how many people notice this, but I think the comment is taken out now, a newer version of Bitcoin Core, but in the version I use, 0.6.3, there was a comment right on top of the version message, push version, right? And on that, you send them your timestamp, which is how they know how far your clock's off. And you send them a bunch of other data about you, which is the first message that you send on the network. Hey, I am this node. And they say, oh, hey, this node, I am this node. Here's some data so we understand each other. Oh, hey, I need some other nodes to talk to, whatever. It says, double slash, it says, when NTP implemented, remove this, right? And I'm like, what's NTP? So I looked it up. And this was like in the very, very beginning stages before Nexus was even launched. This was, I was like, network time protocol. So Satoshi already wanted to make the clock synchronized. He just made the median time to get it out there. And to just put the test out, because implementing NTP would be a big task, especially because NTP is kind of a little bit centralized. It works off of a singular server. You can make that decentralized, but I start with the time. The clocks, in Bitcoin need to be synchronized as much as possible, even if it's, not to the accuracy of NTP, which would be to the millisecond or hundreds of milliseconds. They should at least be synchronized to a second, or, within a smaller fraction of that, because, timestamps are a huge thing. A lot of people say, oh, Bitcoin's a time-stamping engine, which is true to a point. There's a lot of other factors in it, but that is one of the core things, is like time-stamping transactions and showing when they happen. Others is verifying the UTXOs and the proof of work and validate these timestamps in the UTXOs, let alone all the other components. So the time is, I think, a very, very core thing. And that's actually why I started developing Unified Time, because I saw that comment and I'm like, well, let's look at NTP. And then I started saying, there's amplification of task vectors on NTP. Okay, well, let's see how it's designed. Let's build something a little bit better. And so, first thing that would be a really easy drop-in would just be Unified Time, which it wouldn't even have to be a consensus update or a rule. They could still allow a 2-hour allowable clock drift, and then the median time passed for the previous block. But, anybody that updated it would be able to start synchronizing the clocks at the same second, which then could prepare the times eventually to say, all right, well, let's lower our drift to an hour now. Let's lower it to half an hour then, and let's lower it to 10 minutes. And then let's get it to 5 minutes, and then 1 minute, and then 10 seconds, And they can slowly be implemented that way. And then another big thing would be the back end of it. Now, I was just mentioning earlier about how the Bitcoin back end is kind of using, it's just a pretty simple socket routine. I can tell he's an old school programmer because he still uses buffers and different things like that. Not to say that I don't use buffers, I just use it a little differently, but that's kind of the conventional way to socket program. I've kind of developed my own style with it, but if you look at it that way, the Bitcoin backend is processing all of the nodes. Like, so if you have 150 nodes, let's say the maximum default is about 100 connections. that are incoming. So you're processing 100 connections. I mean, every time that loop goes, it has to go through 100 different nodes on one thread. It has to first, did this node time out? Okay. Nope, it didn't time out. Does this have anything to read? Okay, read as many bytes into this buffer as I can. Does it have anything that it have pending to write? Okay, we'll send that right. Okay, goes through that 100 nodes, and then once it gets through them, it goes to the top, and then it says, are there any new nodes that want to connect? All right, bring new nodes in, blah, 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 blah. And that itself can get really slow. And, you know, a lot of people, you know, one thread for one core is the most efficient way, but I found a certain balance with kind of using sleeps and thread schedulers on the operating system level to make it work, you know, with 50 threads, 100 threads, instead of just one. And so everything has gone there. And then there's another thread that's thread message header or something like that. And then there's send messages, and then you have your import and then it calculates. So basically, when a new message comes in, it reads from the buffer and it searches. If you look, there's 4 bytes on the header now. It's, you know, a unique 4 bytes so that it knows, well, the reason for those bytes is partially to know if that's a Bitcoin message or that's, you know, to distinguish different protocols. But the other thing is it reads through your buffer and finds those 4 bytes and knows that's the start of the message, which then again, let's say you have 100 or 1,000 bytes. That's 1,000 iterations the CPU has to do when it doesn't really need to do that if you program the message packet a little bit differently, you know, if you have them processed, you know, in parallel. So that basically is a big summary of the threading and the networking backend where, I mean, it's still running on a lot of that technology, which, you know, can slow things down on a certain respect where hardware is not utilized to its fullest in that perspective. And then, you know, other things are too, like the database system. So, you know, we're using LevelDB right now for the block index. Well, you know, there's block index, which is C block index, which is basically referencing a file position in BLK0001 .dat or 002, blah, 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 which is basically a raw dump of a block, right? A raw dump just means a serialized into bytes. Serialized means you just turn it into zeros and ones. And so the C block index has to be loaded. If you ever load up your wall, it says loading block index. All you're doing is you're loading from either BerkeleyDB or LevelDB. It depends on what version you're using, how old it is, because BerkeleyDB is a lot slower. It has to go then and say, okay, this is the file that I'm reading from. This is a binary position. And then the same thing with the transaction index, DTX index, which is what file, then what binary position is the transaction in that raw block. And then how big is this transaction? So those are all used to reference because otherwise you'd have to read through millions and millions of bytes to find, okay, well, what block is this block? Well, I'm going to have to deserialize every point and find out what's what. So C block index works. But I mean, I haven't really seen too many changes in that architecture, which I think could seriously be improved substantially if, you know, I mean, there was, you know, a different type of database system, maybe a key value or something that works in both of those perspectives. So, like, something I've developed is, like, what's called a lower-level database. Now, the lower-level database kind of acts like that on itself with its keychain, and then only the keychain needs to be initialized in the LLD, which then it knows what sector, what file, and the other cool thing is what node. When it's completely done, you'll be able to essentially set a certain amount of data that your node wants to service. And in that perspective, you'll be able to basically have the Bitcoin blockchain stored on thousands of nodes where they don't have to store the same copy. But the problem in that is you get things called Sybil attacks and other things like that. Well, a Sybil, and that's actually one thing that, proof of work prevents is a Sybil attack, because a Sybil attack basically means there's, let's say, 10,000 Bitcoin nodes. I can put up 10,000 nodes and attack the network with my own data. And if it's a majority rules on the nodes, then bam, you can manipulate the whole blockchain. But since it's a proof of work, then your cost to make that data is in the proof of the work, so that you wouldn't be able to Sybil it that way. You'd have to Sybil it with the actual 51% of the hashing power, which is such a high cost that nobody would be able to pull that off these days. So basically, this gets into the idea of, well, if it's a trustless system, shouldn't the system have a computational trust system so that we don't have to trust them? We trust mathematics, and that's it. I don't trust this person's character or this node's whatever or what anybody says about it. You have a mathematical trust. So that's something Nexus has been doing for a while, and we're actually improving to this. Think about it as two different levels of trust. I guess I can give a good example in layman's terms of, let's say, a relationship between you and me, Richard, right? So we both have our reputations, and we decide to talk to each other from our reputations, right? And then that's kind of something everybody can know. Think of that as your objective trust, right? So, I know who you are and you know who I am, so therefore we decide to start talking because there's enough merit there to say, well, this person's somebody worth talking to, not somebody that's just going to fill my head full of crap. And so then as you build that relationship together, you build your own personal trust between each other. So as we've continued to talk over time, we've built a personal relationship with each other, which either reflects positively or negatively on that reputation, right? But you and me are the only ones that know how much we trust each other, right? And everybody else, how much our public reputation is trusted. So think of that applied to computers. So every computer will have its own trust, right, that everybody on the network knows, where if you're the first guy on the network, you say, who are the most trusted nodes? All right, these guys. And then they start talking to them. And then if they talk to them over 6 months to a year, they'll build a really good repertoire. All right, I know this guy always gives me good data. He's an honest node. He's not selfish mining. He's not doing all these things. This would be done on the computational level. You would never have to worry about it. Your computer would just do that. And then you build a bias of what nodes you like to talk to because of the ones you trust. And then other guys that trust you can say, hey, do you trust this guy? You'd be like, yeah, he's got a good reputation. But the thing is, you can't manipulate a private trust because nobody knows what the trust is. You can't change that. That's something between you and that node. And the longer you know that person.
Even if it was a private trust, wouldn't they know because they would see a certain node interacting with a certain node more often than others?
Yeah, I mean, they'd be able to see that, but they really wouldn't be able to know if you're interacting too much. They'd be able to see if they talk to you and ask who you trust, you can say that, but you don't have to give the threshold of how much you trust them. You can just say, yeah, I trust them. Just like somebody would say, hey, do you trust your friend over here? You'd be like, yeah, I trust him. But you wouldn't tell them all the experiences you've had and every reason why you trust him. You'd just be like, yeah, they're decent. And based on that trust, that builds that way. So what that eventually starts to build is an ability for nodes to distinguish from one another who they want to trust and not, and also build a global network reputation, which is going to be kind of a reason for them to talk to. So if, let's say, new guys come on the block with 5,000 nodes and trying to start spamming bad data, we're going to be like, hey, new guys, like we've been talking to all my senior nodes over here for a long time, and you're coming here trying to give us crap. We go to the senior nodes, hey, is this data good? To say, no, we disagree with that data too. You'd be like, perfect. Well, now we know on that perspective that these guys are most likely not honest nodes. So, all right, you're never going to have the ability to get that reputation because we know you're trying to attack. So the network can kind of start to understand its normal modus operandi, I guess you could say, how it normally operates, and distinguish the difference between the different types of nodes that they want to talk to. It goes back into the lower level database. Now that's a way that you can validate the integrity of data that other people host so that the nodes you trust are the ones that you talk to for certain pieces of the blockchain. So that, I mean, even if the current architecture as it is with, let's say, 20 megabyte blocks or 100 megabytes and the blockchain becomes terabytes and terabytes, we won't need massive computers to run them. I mean, you can run a normal computer on it and just serve it to a piece of the chain, which is called fracturing and partitioning. So the trust system allows you to validate the integrity of data and pieces of that data to make sure that they're not manipulating you, but make sure that you don't have to hold all of it on yourself so that you only have to trust what you're doing. Because that's just, as it grows and grows and grows, that the inefficiency will compound and multiply, which can create issues like we're experiencing now.
So does that mean essentially you want to give more power and a vote to nodes right now, at least in the Bitcoin network? Miners can spin up their own nodes. So, I mean, it's kind of funny when you look at it. Miners, they have their own nodes. What about the rest of the nodes out there? Are they worth anything, or are they just, they get no reward? They just kind of sit out there and take up space. I mean, what do you think is going to happen to the network of nodes on Bitcoin over time, as mining, continues to stranglehold, as you say?
Well, we're going to see what we've been seeing. We're going to see less and less nodes because there's going to be less and less need for them. I mean, the only reason there's going to be nodes is to make sure it stays decentralized. But why am I going to run a node when I have to build a special computer for it? I have to pay a monthly, fee for a server to run it, or everything else associated with that. I mean, it's just, for lack of better words, the miners kind of have, what do we say, the control of the chain when it's really very small percent of the total amount of people invested in Bitcoin. So everybody that's invested in Bitcoin should have the right to say what they believe it should be. Otherwise, we just create another pyramid system, which is what the governments in the world are nowadays.
So nodes are going to become fewer and they can become more concentrated in the hands of miners if things continue as they are.
We've seen that. That's why Dash has a higher node count, and they're bragging about that because they made a node incentive system. Now, I personally don't like the idea of master nodes, but the concept and the application of it is proving valuable in the sense of producing more nodes and making a reason for you to produce nodes and also giving people a chance to have a vote. But right now, to have a vote on the Dash network is a $70,000 vote, and that's only going to get worse and worse. So master nodes are going to become the same thing as miners. It's just like one step better. But better is good, but if we don't keep innovating forward, like as this adopts, then it's going to come to points where we're going to reach stalling situations where it's like the momentum can't push forward because hardware and the software can't handle that.
Yeah, makes sense. So you're saying to create a system where a node would have many different types of trust signals. One is a public one, and then with any other nodes it interacts with, it has different trust levels.
Yeah,
the previous interaction.
A subjective thing. And think about it too. If you have a node that's running for 2 years and you've got all the nodes that you talk to, and most of the nodes in the network, and you've built a trust with all of them, and all the nodes know all the nodes either by proxy or by direct connection, and new guys on the block trying to poison it, or new coming into the blockchain and trying to throw nodes in poisoning data are not going to have an advantage at all. They're going to have a disadvantage because they cannot make back that time. You have 2 years more trust with the network than they will ever gain. So even if they try to do an attack for a year and pretend to be honest and plot an attack, they may poison some of the newer guys, but the older guys, the core ones, are going to be like, oh, no, like you're directly disagreeing with my senior nodes that I've known for 2 years longer. Well, I've only known you for a year. So 3 years for these guys and 1 year for you. Now you're giving me bad data. I'm going to trust the data of the guys that I've known longer. And that's kind of really how humans work in interaction. And I think that's something that, we can model into cryptography and model into these programs is like how it's already been done. Because node interactions, exchanging data and information is not much different from two people exchanging their experiences and their knowledge and knowing what knowledge is BS and what knowledge is valid. And that's all based on trust and reputation.
Okay, that makes sense. What about the proof of work is tremendous right now with Bitcoin's hash rate. What about the encryption algorithm itselth, the SHA-256? Is there a need to upgrade that, especially in light of quantum computers that are coming?
Well, see, that's the caveat. That's the problem. We go back full circle to the beginning of the conversation with ASIC Boost. We got hundreds of millions of dollars invested in mining on it. That algorithm is not going to change anytime soon. The only thing that would possibly be able to be implemented is, let's say, another Bitcoin mining channel opens up with a different algorithm that can slowly get a small fraction of Bitcoin to post a little difficulty or something. You're just not going to be able to eliminate that because there's too much money invested in it. And money is really what's making the shots here. It's so yes, I believe we do need to look into that. I've done a lot of that with Nexus with the 1024-bit hashes, prime number, multiple channels, and 571-bit keys, and everything like that. Because there's, 1,000 qubits will break an SEC Fire 256K1 key, which is what we have right now in Bitcoin. Now, they're at 3, 4, 5 qubits now. Who knows what else? But, quantum computers are going to be more devastating than we really realize. Now, a lot of the Bitcoin developers said, hey, we'll take care of it when it's time. And it's like, yes, that is a good philosophy. I understand why fix it when it's not broken. But the other question is, well, how big is Bitcoin going to be when that happens? And based on how hard it is for us right now to even update, right? How easy is it going to be for us to update some of the cryptography? And another thing, too, is when Bitcoin mining, Hashcash proof of work, if you look at Adam Back's original paper, it talks about how it's partial collisions, basically. Now, Bitcoin is using partial collisions, but with zeros, which allows you to basically find a smaller hash. When the difficulty adjusts, it's just basically saying you have to find a smaller number. Because the smallest number, 1, can be a hash with all zeros and then 1 at the end, but that should be probably the hardest hash to find. You know what I mean? Because that's going to be the most insecure. That's going to have the highest number of partial collisions. Right now, Bitcoin is basically breaking SHA-2. I wouldn't say that it's broken it or it will break it, but it's weakening it as it's using that to strengthen Bitcoin. So it's only a matter of time, really. But the question is how long, and do we need to make the preparatory stages now or later? That's why I chose to just get it done at launch so we never have to worry about this in the future. Now, it can be upgraded. Let's say, the private keys algorithm becomes compromised, or they find that it's going to be compromised. Say they get to 500 qubits and they're already starting to break Bitcoin keys. Oh, crap. Well, what are we going to do about that? Well, we're going to want to put them in new keys. But wait, Satoshi has, 1 million Bitcoins, right? Let's say he's alive or dead. We don't know. Let's say he doesn't have access to those private keys. And, okay, well, all those keys, that means that none of those funds can be moved because those keys are locked. Now, let's say they crack those keys and find the private keys. Anybody that cracks it has access to those 1 million Bitcoins, which could be just liquidated. So if the keys, the keys can be upgraded and the hashing can be upgraded, yes, but everything previous to that upgrade is rendered insecure. If, let's say, they find it to be insecure. So it could cause a very, very serious cataclysm coming into the quantum computing age, which we are seeing now. Now, it's good to think forward, and I say sooner rather than later with Bitcoin, because Bitcoin's getting bigger and bigger and bigger by the day, by the year. And that just means more and more and more and more pieces with less and less and less ability for those pieces to communicate and share their opinion. So it's going to become exponentially more difficult as the days go forward to make a change like that. Now, I don't think it would be the fate of Bitcoin, positive or negative, but I think it could cause a lot of problems, especially, let's say, the NSA takes their quantum computer. Let's say they have 100 qubits already, and they're already trying to crack it. They crack Satoshi's keys, that's going to be big. I mean, people are going to be like, Satoshi's alive, or Satoshi's dead, or, oh, the NSA cracked it, or whatever. It's just like, there's already rumors of random keys, having seed that, was generated by the NSA as a backdoor. That's why in the future with us, we use 571R1. We use a random curve, which people are going to be like, oh, yeah, the NSA can crack it. But it's like, well, when we get to the point when we're done, probably on Quartz or Obsidian for Nexus, those are, version 4.0 and 5.0. I'm working on Tritium right now. You'll be able to basically say, all right, well, I want to choose my random seed now, and I'm going to seed my seed off of the blockchain, which means there can't be any NSA backdoors, and bam, we got bulletproof keys. So there's a lot of things that should be considered and looked at right now, but I think everybody, this is an assumption again, I think most people are looking at the now factor and not as much into the future factor. What are we going to do now to make Bitcoin better now? Instead of thinking, what are we going to need to do in 5 years? It's going to be a hell of a lot easier to do now, but it will be in 5 years. And that kind of
makes sense.
I guess the best answer for that question.
All right, so last question or two. I know it's anybody's guess, but knowing what you know and seeing what you see, what's your guess on what's going to happen with Bitcoin in 2017 and maybe even next year, the next year and a half, 2 years? What do you think are going to be the ups and downs?
I guess I'll answer it a little bit out of context, but around the same context. I think we're coming to a very, very significant point in the evolution of Bitcoin, where I guess Darwin stated that an evolution of species, right? You have to come to a precipice, which is the brink of destruction, to truly choose, are we going to expend the energy to evolve or not? Because life resists change because change takes energy. Just like you burn more gasoline when you accelerate on your car versus when you're going at a static velocity. It's because changing things takes more energy to initiate that movement. But once that movement's going, it's got that momentum. So we're approaching an evolutionary leap or collapse in Bitcoin, really, where it's, it's all been money and fun and games and dreams and possibilities and let's take over the world up to this point. But we're really getting close to a point where we're going to start to see our precipice. And that's what's rumbling right now is people are starting to see this. It could erupt into a civil war that destroys Bitcoin and nobody does anything about it. And we inevitably don't survive because just the world is changing around. Bitcoin needs to evolve to acclimate to the world. We look at things, Venezuelan economies are collapsing. Brazil had martial law. Everything in the world is destabilized. And Bitcoin is a safe place. It's a safe. So we're going to really come to a point as, all of us Bitcoiners looking at it and saying, all right, now what can we do to keep this at 5? Where can we meet in the middle? What are we going to do to make it evolve to the next step? Because we're approaching that precipice. I don't know if it's this year or in 2 years or 5. where we're going to have to do something like big, not just like block size of base or not just SegWits, but the whole way everything runs. We're going to have to figure something out. Otherwise, we may not survive forward, or we may just reach a cap where Bitcoin really can't grow anymore until it evolves. Now, that can sustain itself for a while, but eventually that kind of deteriorates it, because then other people are going to put their money in other projects that can. So really, the next few years are going to be very, very significant years in Bitcoin, in my opinion, where we're going to either have to come together and figure out how we're going to make it work for everybody, or we're just going to have to see it turn into another type of centralized system.
What do you, last question, what about the role of altcoins? You know, what role do you think Nexus will play? What about the other altcoins? Do you think that they're going to come to the fore and take over, or what role will they have?
Well, I mean, that's a very open-ended question. I mean, the role of Nexus, we've got a lot of different roles. Like, you know, how we're working on relationships in the aerospace industry for immutable technology and space with CubeSats, which we're making a lot of headway that way. You know, other roles is just providing quantum tiered technology, showing different types of proof systems, showing how they work, you know, leveling the playing field. I mean, and just saying, hey, well, if you want to see if this works, here it is. Now, roles of other altcoins, like, this is something that was really interesting to me more recently, because I never really saw the value of a clone before, ever, until I saw this happening with Bitcoin Unlimited and segregated witness and Litecoin. Right? Litecoin is pretty much an absolute copy of Bitcoin. And something just clicked in my head a few weeks ago. I was like, now I see a value for Litecoin, because if Bitcoin, let's say, continues in a trend of civil war and fighting and whatever, and it escalates, like, where else can you put your money? Well, Litecoin is the next best Bitcoin. You know, it's not the valuation of Bitcoin, but it's a safe haven. And Litecoin is going to be proving segregated witness and how it activates and how it works, and saying, hey, look, now our transaction capacity is up to here. You know, now this works. So, you know, altcoins are going to be in a bunch of different ways. Right now, they're starting to be recognized for the utility and expansion, kind of like Linux, you know, bred so many different variants of Linux. This is really cool with altcoins, because now we're starting to see, hey, you know, Bitcoin is king, yes, but if Bitcoin doesn't stay king for their people, you know, because that's what a king should do, is look after their people, then people are going to find another king. And so if Litecoin adopts segregated witness, I mean, personally, I think it's only a matter of when, that's going to be pressure on Bitcoin. Hey, look, Litecoin's growing substantially because Bitcoin would not adopt this. Now, so if Bitcoin really wants to stay in that perspective of no alternative currencies, we don't like them, Bitcoin is going to be forced to make some moves. So in a way, they act politically. In a way, they act as testing beds. Other ways, they act as experimental places to breed new technology. And in other ways, it acts as just areas of innovation.
Very interesting. All right. Well, I knew you had some interesting perspectives and a lot of knowledge. So, yeah, thanks for taking the time. You know, I really appreciate it. And listeners got to listen to this interview probably several times. There's a lot in there.
Yeah, really good questions as well, Richard. I always enjoy our conversations. We always have a really good energy between us. It's a nice synergy.
Yeah, thanks.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.